Hello and welcome to another chapter of Science Class 10th, that is Metals and Nonmetals. This is a small chapter which deals with four topics. First, we are discussing about the general properties of metals and nonmetals. Second topic that we're discussing is about the chemical properties of metals and nonmetals. Third is about the reactivity series. The topic of metallurgy and corrosion have been deleted from the curriculum for this academic year. So without any time delay, let's get started with the topic. First one is the physical properties of metals. There are 6 properties which are mentioned in NCERT. So let us understand each of these properties one by one. First property of metals is that it is having a luster. So what is the meaning of metallic luster? Metallic luster means it is the ability of the metals to shine when some light falls on it. So metals in their pure state have a shining surface, and this is known as metallic luster. Second one is known as the hardness. What is hardness? Hardness is the rigidity of the material, and the hardness of a metal varies from one metal to another metal. Next is the malleability. Malleability is the ability of the metals to be beaten into thin sheets. We can see thin sheets of aluminium, right? So that is because of this ability, so called malleability. Next one is the ability of the metals to be drawn into thin wires, that is known as ductility. So it is due to this ductility that we have copper wires which is going in our cables. Next is the conductivity. Conductivity is the ability of a substance to conduct or to allow electricity or heat to pass through it. And metals are the best conductors of electricity as well as heat. And among metals, silver and copper, these are the best conductors of heat. Now, talking about the electricity, again copper is having the maximum conductivity, and lead and mercury, these are the metals which is having least conductivity. That means they are poor conductors of electricity. Now the last property is known as sonority. Sonority is the sound that is produced by the ringing of some substances on metals. So when we are hitting hard on any substances, any metal substances, then it will produce a sound. So this ability of the metals to produce a ringing sound when striken on it is called as sonority. So these are the different physical properties of metals. First one is a metallic luster, second is the hardness, malleability, ductility, conductivity and sonority. So now let us move on to some exceptional metals and non-metals. First one, we have seen that all the metals are solid at room temperature, but we have an exception here, that is mercury. Mercury does not exist as a solid in room temperature. Next, we have seen that metals are having high boiling point as well as high melting point because they are good conductors of electricity as well as heat. But there is exception here, that is gallium and cesium. Gallium and cesium is having very low melting point. Next, we have seen that only metal shows luster, but we have an exception here, iodine, which is a non-metal, is having luster. Next, carbon, that is a non-metal, can exhibit various allotropes. Allotropes means different forms of the same element. Example for the allotropes of carbon includes diamond as well as graphite. And this diamond is the hardest substance known so far. It is having very high melting point and boiling point despite of being made of a non-metal. Similarly, graphite is a strong conductor of electricity despite being made of a non-metal. And we have studied that non-metals are poor conductors of electricity, but an allotrope of carbon, that is graphite, is very strong conductor of electricity. Now we have studied that metals are very hard, but there also we have an exception, that is alkali metals, lithium, sodium, potassium, rubidium, etc. These are very soft and hence they can be cut into pieces by using a simple knife. Moving on with the chemical properties of metal. The first chemical property is the reaction with air. So when metals react with oxygen, it will form metal oxide. So if I write a general equation, we can write M plus O2 giving MO2 as a general equation. Or it can be different forms, like MXOY is the general representation of a metallic oxide, because aluminium oxide is Al2O3. Sodium oxide is Na2O. So different types of formulas are possible for oxide. So general formula for oxide is better to use this one, that is MXOY. So if I take sodium, sodium reacts with oxygen to form sodium oxide, that is Na2O. Aluminium reacts with oxygen to form aluminium oxide of the formula Al2O3, and copper reacts with oxygen to form copper oxide, that is Cu2O. Now, what is the nature of these metallic oxide? In the previous chapter, that is acids, bases and salts, we have discussed some important points regarding the acidic as well as basic oxides, that is the metallic and non-metallic oxides. We have seen over there that metallic oxides are basic in nature and non-metallic oxides are acidic in nature. We have seen that carbon dioxide, sulfur dioxide and nitrogen dioxide, they are acidic in nature, whereas sodium oxide, similarly the copper oxide, these are basic in nature. That's what we have seen in the previous chapter. So here also we are discussing the same thing, that metallic oxides are generally basic in nature, whereas we have some exception, that is of aluminium oxide Al2O3, which can react with both acids as well as with bases. That is why they are considered as amphoteric substances. Amphoteric substances are those which can react with both acids as well as bases. So aluminium oxide can react with acids as well as bases, and when aluminium oxide is reacting with an acid like HCl, it will form a salt AlCl3, and when it is reacting with a base like NaOH, it results in the formation of another salt, which is sodium aluminate, NaAlO2. So this is the amphoteric nature of aluminium oxide. And most of the metal oxides are insoluble in water, but again some exceptions are there, that is sodium oxide and potassium oxide. Sodium oxide and potassium oxide, they dissolve in water to give alkalis. Sodium oxides will give sodium hydroxide and potassium oxides will give potassium hydroxides when dissolved in water, and both of these substances, that is sodium hydroxide and potassium hydroxides, they are strong bases in nature. Let us now talk about the reactivity with oxygen. We have studied the reactions with oxygen. So now let us see what is the reactivity order of different metals with oxygen. If I talk about the elements such as sodium and potassium, we can see that it vigorously reacts with oxygen. What is the meaning of vigorous reaction? If we are simply holding a piece of sodium or potassium, if we are just keeping a piece of sodium or potassium in open air, then what happens is that it catches fire easily. So it is really dangerous. That is why we are storing the sodium and potassium in kerosene oil, because if it comes in direct contact with oxygen, it catches fire easily. The process is exothermic and it releases a large amount of energy, as a result of which it catches fire easily. So that is why we are storing the elements sodium and potassium in kerosene. Next, metals such as magnesium, aluminium and zinc. Also we have lead. So these four elements, when they are reacting with oxygen, they will form a coating on the surface. So this we have already studied in the first chapter, where we have discussed the experiment where we are burning the magnesium ribbon. So there, first of all, we are rubbing the magnesium ribbon with sandpaper. Reason is because this magnesium reacts with oxygen, it reacts well with oxygen, and it will form a coating of oxide over it. And this coating of magnesium oxide over the magnesium ribbon will prevent further process of oxidation. So that is the reason why we are rubbing it using a sandpaper. So we can say that they are moderately reactive metals. Whereas iron does not burn on heating. Whereas iron fillings, if you are putting iron fillings on the flame of a burner, then they will burn vigorously. But iron as a whole, it does not burn on heating. And silver and gold does not react with oxygen at any temperature. So that is the exceptional case. We have some elements which do not react with oxygen at room temperature or any other temperature, that is silver and gold. So from here we can see that the reactivity of oxygen is maximum for sodium and potassium, moderate reactivity for magnesium, aluminium, zinc and lead, little more lesser reactivity for iron, and least reactivity for silver and gold, also for platinum. So now let us move on to the next one, that is reactivity with water. So metals, when they react with water, they will form metal oxide and hydrogen. Please keep this point in mind. Metal react with water to give metal oxide and hydrogen gas. This is a general case, but there are exceptional cases also. First, let us see the reactivity of metals towards water. There are some metals like sodium and potassium which are violently reactive and catches fire easily. Next, calcium is moderately reactive. If you are putting some calcium in water, it releases some heat, but this heat is not enough to burn calcium. This does not catches fire, so that is moderately reactive element. Next, we have less reactive elements such as magnesium. Then there are non-reactive elements at ordinary conditions such as aluminium and iron. They does not react with cold or hot water, but they can react with steam. Now when they react with steam, they will form their corresponding oxides and also they will give hydrogen. Next, we have elements which do not react at all, that is lead, copper, silver and gold. So these are the elements which never react with water. So different elements are having different reactivity. Some reacts fast with water, some react slowly with water, whereas some elements do not react with water. So here you can see the various equations. If a metal is reacting with water, some can form hydroxides as well. That is these three: potassium, sodium and calcium. Potassium can form potassium hydroxide, sodium can form sodium hydroxide and calcium can form calcium hydroxide. Whereas the elements such as aluminium, iron, etc., they will be forming their corresponding oxides. So two cases are possible. Either there can be formation of hydroxide with these two cases, there can be formation of hydroxides, and in these two cases there is formation of the corresponding oxides. So with magnesium and with water will form magnesium oxide, and this will never undergo reaction with water. Now moving on with the reactivity of metals with dilute acids. So this we have studied in the last chapter, that is acids, bases and salts. That is when metal reacts with dilute acid, it will form a salt and also it will generate hydrogen gas. So magnesium plus dilute HCl will give us magnesium chloride, which is a salt, and it also evolves hydrogen gas. Whereas when metals are reacted with dilute HNO3, which is nitric acid, metal nitrates are formed, but hydrogen gas is not produced in this case. What is the reason? Dilute HNO3 is a very strong oxidizing agent. Since it's a very strong oxidizing agent, whatever amount of hydrogen that is produced, that is getting oxidized. Due to this reason, it does not produce hydrogen gas. Whereas metals like magnesium and manganese, they can react with dilute HCl to give H2 gas, even very dilute HCl. We can use that word very dilute. Even if it has 0.1% HCl solution, these metals, that is magnesium and manganese, they can react with this acid so as to produce hydrogen gas. So here we can see that the reactivity order is maximum for magnesium. Moderate reactivity is seen in the case of aluminium and zinc, and iron and copper are showing the least reactivity because there no hydrogen is released, no bubbles are seen over there. Now let us see another reaction, which is the displacement reaction, which we studied in the first chapter. What is displacement reaction? Displacement reaction is a reaction in which the more reactive metal replaces the less reactive metal from its salt. So if we have a more reactive metal A, that will take up B because B is having comparatively lesser reactivity from its salt, and now we will be getting AX plus B. Now, what decides this reactivity is the reactivity series. Reactivity series is a series of elements in the increasing or decreasing order of reactivity. So this, we are writing the reactivity series by observing through different reactions. We have seen the reactivity of oxygen, reactivity with water, reactivity with acids. So by seeing many such reactions, we are coming to a conclusion that this is the reactivity order. These elements are very reactive, whereas these elements are least reactive, and so on. So in every case we have seen that potassium, sodium, calcium, these are highly reactive, whereas we have seen that gold and silver, they are least reactive. So based on that, we have prepared a series, and this series is known as the reactivity series. Now the problem is by hearting this. So by hearting of such series is easy when you make your own mnemonics. So if you can't make one, then here is one for you. King of Nagaland came Meghalaya. All Sioux feared public homes. Cute, mermaid, gold, and silver. So, what is the meaning of this? So, let us take one by one. King of Nagaland came Meghalaya. King, that is K, of Nagaland, that is NA, came Meghalaya. So we studied the first four elements. King of Nagaland came Meghalaya. So that is potassium, sodium, calcium, followed by magnesium. Next, all Sioux feared public homes. All, that is aluminium, Zoo, so it is zinc. Next is feared, that is Fe. Next is public, Pb, and H, that is hydrogen. Home is hydrogen. So I will write it over here. This is Al, this is Zn, this is Fe, this is Pb, and this is hydrogen. Next is cute, mermaid, gold, silver. Cute, that is Cu. Next is mermaid, that is mercury, that is Hg. And then we have gold, that is Au. And then we have silver, that is Ag. So here we have potassium, sodium, calcium, and magnesium. So this is the mnemonic by which you can study the reactivity series easily. If you can make your own mnemonic, then that's also fine. If no, you can study the same mnemonic. King of Nagaland came Meghalaya, that's the first set. Next set is all Sioux feared public homes. Next one is the cute mermaid, gold, silver. Next, we are going to study about a very important topic, which is the formation of ionic compounds, that is ionic bonding. So starting with ionic bonding. Now what is ionic bonding? It is also known as electrovalent bonding. So it is a special type of bond which is formed between a cationic species and an anionic species. So let us see how this bond is formed. So let me take an example here. Let us take a general case. Let us understand with an example and then we'll move on to the chemical aspects of this bonding. So we have one person A. This person A is having, say, 1000 rupees with him. And another person B is having, so let us take 1100 rupees here. And this person is having 900 rupees. So if both of them are going for a cinema, they have to take a pass. Suppose the cost of this pass is 1000 rupees. So now this A is eligible to get into the cinema theater, right? Because he is having 1100 rupees. So even if he take the ticket, he have 100 rupees left with him. But what about B? B cannot get in because he have only 900 rupees. So if he get another 100 rupees, then he can also become stable and he can also get into the cinema theater. So now what will our A do? A is a very kind-hearted person. So he is going to donate some money to B. That is, he is going to give some 100 rupees to B. Now what happens is that A is having 1000 rupees and A is also very stable because he can also go for the film, and B is also now having 100 rupees more with this 900, that is 1000 rupees, and now B is also stable. That means he can also get into the cinema theater and he can also watch the movie. So both are happy and now a bond of friendship is formed between A and B. So bond is nothing but friendship in chemistry also. It's a sort of friendship between two atoms. Either it can be due to sharing of electrons or it can be due to exchange of electrons. So in this case it is due to exchange, right? So let us take the same analog in chemistry now. So let us take a molecule, that is sodium chloride. So in the case of sodium, as per class 9th, we have studied about the Bohr model and there we have studied about the electronic configuration. So according to Bohr model, the electronic configuration for sodium is going to be 2, 8, 1 because the sodium is having an atomic number of 11. So now this is a complete shell. This is also a complete shell, but the next one is incomplete. It needs 7 more electrons to become complete. but that is very difficult, right? Getting 7 electrons is very difficult. If we take chlorine, chlorine is having 2, 8, 7. So that is already having 7 electrons. So if it is getting one more electrons, then it can become stable. So the same story here also. If this one is moving on to this side, then what happens is that this will become completely stable, and now this will also become completely stable, and now a bond can be formed between sodium and chlorine. So this is known as electrovalent bonding. So how do we define electrovalent bonding? In a metal and a non-metal bond, the metal loses an electron to achieve stable configuration, while the non-metal gains electrons. Thus, an ionic bond is formed with the transfer of electrons from metal to non-metal. The compounds which contains ionic bonds are called as electrovalent compounds. Examples includes potassium chloride, sodium chloride, magnesium chloride, and so on. So let us see the formation of sodium chloride here. So sodium is having 1 electron extra and chlorine is deficit of 1 electron. So that electron is given to chlorine, and now there is a bond formed between the sodium and chlorine molecule, and that results in the formation of sodium chloride. And what about magnesium chloride? Magnesium is having 2 electrons in its outermost shell, or the valence shell, these 2 electrons. So these 2 electrons are given to 2 different chlorine atoms. So now 2 chlorine atoms are going to become friends. Suppose the person A was having 1200 rupees and he met 2 person who is having 900 rupees each. That is person B and person C. Now he gives 100 rupees to person B, so he is also stable now. And he is giving 100 rupees to person C also, so he is also stable now. So a bond will be formed, a friendship will be formed between A and B, and also between A and C. So the same thing is happening here also. A bond will be formed between magnesium and this chlorine, and magnesium and this chlorine. So that is why we are getting 2 bonds over here, and this is the formation of magnesium chloride. So this is how an ionic compound is formed. It is also known as an electrovalent compound. Now this bond is a very strong bond because it is an electrostatic force of attraction, and electrostatic force of attraction are very strong in nature. So now let us look at some of the important properties of ionic compounds. First one is that since this bond is very strong, the compounds will be hard and brittle, and if we are applying pressure to this will break, like the sodium chloride that will break when pressure is applied. Otherwise it does not break under ordinary conditions. They are having high melting point and boiling point because the atoms are in very close proximity, and also they are held together by very strong force of attraction. Next point is regarding their solubility. They are soluble in water because water is also formed by the similar way. So always you have to remember this point, that polar solutes are soluble in polar solvents. So these are polar solutes, that means charged solutes, so they are soluble in charged solvents. That is, water is also a charged solvent, so they are soluble in water. Whereas in the case of petrol and kerosene, they are uncharged molecules or unpolar molecules, non-polar molecules, so they does not get solubilized in those molecules. Now talking about the conduction, in solid state they are poor conductors because the ions are not free to move about. If the ions or electrons are free to move about, then they will conduct electricity. And when is that possible? It is possible in the aqueous state. So in the aqueous state, the ions are free to move about, as a result of which they are good conductors of electricity. Also in the case of molten stage, they are going to be good conductors of electricity. So this was all about this chapter, that is metals and non-metals. A very small chapter which deals with just 4 topics. First one was the general properties of metals and non-metals. Then came to the exceptional cases of metals and non-metals, the general chemical properties, followed by reactivity series, and then come the ionic bonding. So I hope you like this video, and if you found this as an informative video, please do share with your friends, and also do not forget to like, share and subscribe to this channel. See you again in the next lecture. Till then, goodbye and happy learning.